Okay, this time I have the same configuration before and the integrated circuit with the programmable filter. In this case, the circuit has an interface with the Arduino Nano, and this received a command by the USART peripheral in order to reprogram the cutoff frequency of the circuit. So you must consult all the codes for the frequency decided to this new function of the circuit. So first I will remove the sweep, pressing again the sweep mode button, and I will establish a new frequency of 5 kilohertz. As you can see, the system has no the new integral behavior. So I will reprogram the circuit to 5 kilohertz. How? According to the datasheet, I need to send the command for B channel. This integrated circuit has two filters and additional operational amplifier, but in this case I will configure the 5 kilohertz cutoff frequency with the code 85. So I send this new command, and as you can see, the circuit has been reconfigured and has again this behavior of integration function. If I use the square wave, you can see the same effect or near to line function behavior. And if you use a sinusoidal, you know that the integral of a sinusoidal function is a minus cosine function. So if you start in sinusoidal, after that you have a minus cosine. If I move my cutoff frequency to maybe a kilohertz, you can see this behavior. In this case, the filters implemented in the circuit are system of order 2. So I will reconfigure the cutoff frequency to 1 kilohertz. Okay. So again we have this behavior. I change the kind of signal to triangular, and we have a quasi-sinusoidal signal in the output of the circuit. So you can reprogram as the system behavior needs this cutoff frequency of the integrated filters. So I will use other kind of system, or in this case a PWM maybe. So you move to the special kind of signals built-in. Next page, and the fan test is PWM signal where you can configure the duty cycle. So I will select 700 over 1000 approximately. So I will increase a decade the cutoff, the frequency. Okay, and take a look here. According to Fourier, remember that the first component of the signal decomposition is the direct component. So if I reduce the duty cycle, the DC component, okay, is less than the before test. So if you have a low duty cycle, you have a low DC component. If you have a high duty cycle, you have a high DC component. To check this, I will change the coupling to DC. Okay, this case 2, DC DC. Okay, I will change the trigger. Okay, the resolution. Okay, about the same level. Okay, you have a high duty cycle, high DC component, low duty cycle, low DC component. If we have the duty cycle in the middle, you will have the VCC and half of the DC component. So this instrument, the MP750511, is a great instrument, a wonderful instrument. You can configure the impedance. You could use your own signals or random signals, well-known signals, in this case a triangular waveform, square waveform, sinusoidal waveform. Okay, you have some special kinds, for example, for medical signal processing. You could create or synthesize your own signals according the requirements of your project. Okay, we have an electrocardiogram. We can change the phase of our signal, sorry, and you could use a second channel, copy the features between channels. Okay, in this case I will copy the Dirichlet signal in channel 2 to the channel 1. Okay, if you had the channel power off, that feature is copied to the channel 1. I will turn on. Okay, trigger. I will change the trigger of the scope. Okay. So in this case, the magnitude of the output is very low, so I will change the features of the cutoff frequency of the circuit to modify these behaviors. Okay, I will reduce. Okay. Or you can configure according to the other kind of signals, for example, and a logarithmic or Lorentz kind signal. So, okay, you can see this, and you are able to see this reduced magnitude. So I reduce the cutoff frequency, so the magnitude is lower and lower and lower than required. So I will increase this frequency. You can see that the output is not perceptible, but I will increase the cutoff frequency, and you can see that the magnitude of this signal you could see again. I will reduce. You are no longer available to see the signal. You can reconfigure that, and it's not required to redesign or reassemble the whole analog system. So this is my test bench for the MP750511, and thanks for watching.